Generative Design Setup. In this video, we'll use Edit Model, define a generative study, and we'll solve a generative study. In Fusion 360, we want to carry on with our performance and weight reduction design. We're going to move into the Generative Design workspace and move right into Edit Model. There are already obstacles and preserves that have been created in the bodies folder. So the first thing that we need to do is remove components that aren't needed for our study. As we look through the list of components, you'll notice that there are several components in here that just aren't needed, from the rear wheel all the way down to the chin fairing. Let's go ahead and select all these by holding down the Shift key, right-click, and select Remove. You'll notice that left behind is Generative Swing Arm Parts. This is going to include the axle blocks, and then inside of the bodies folder, you can see that we have the pivot points, pivot 1 and 2. Then there are some additional obstacles, the swing arm right, the shock, swing arm left, and tire, as well as the link preserve. And then there's this last body, body 64, which was a connector obstacle. This gives us an area to build the swing arm inside of, connecting all the way to our pivots and our axle blocks, and making sure that we do have enough space around things like the rear shock and the tire. We do want to come in and clean up some of this geometry as we will be building right up against it. So in Modify, we want to select Fillet and begin by placing some large fillets on the inside edges where the swing arm might be built. We're going to set these equal to 25 millimeters, and then we're going to use the fillet tool one more time, and we're going to add a fillet to the front corner where the shock is. We'll set this to about 35 millimeters, and then we'll say OK. This allows us to make sure that we have a nice smooth transition. From here, let's finish Edit Model and move back into the Generative Design workspace to finish defining our preserve and obstacle geometry. The preserves are going to start with the axle blocks, the mounting point for the suspension, and then we also want to include these pivot points. As we're doing this, I can also see that I accidentally removed a component that was needed. So let's define our obstacle geometry by adding the tires, the swing arm, and the shock, and then move back into Edit Model and identify the component that was removed. We should have some swing arm linkage here, and we're going to have to go back through and take a look at each of the removes, and notice that we have one called Remove Instance Suspension Link. I'm going to right-click and suppress that, and notice that it brings back one of the links. This isn't the one that we need, but we have a suspension crank. So let's go ahead and right-click and suppress this one, and this brings back the crank. This is exactly what we need, and we want to make sure that we avoid it. So for the suspension link, we can right-click and we can resuppress that feature. Next, we'll finish Edit Model, go back to our obstacles, and make sure that we do include the two pieces of that suspension. Now we have everything needed in terms of our obstacles and our preserves. Let's go ahead and hide the obstacle geometry so we're only looking at the things we need to keep. The next step in the process is for us to define the conditions. We're going to be taking a look at several different load cases. So we want to start by first using a structural constraint. I'm going to create a pin constraint on the inside of each pivot. So I'm going to select pin, and I'm going to lock it down in all three directions. I'm going to repeat this process, once again selecting the inside, making it a pin, and locking it down in all three directions. Next, we want to begin to apply some loads. By going to our structural loads, we're going to begin by applying a compressed load. The compressed load will have 1,000 pounds on the axle blocks. So what we're going to do is we're going to select each of these axle blocks. We're going to change the units to pound force, and we're going to set this equal to 1,000 pounds. Another way that we could do this, because we will be changing the direction of these forces, is we could apply them individually to each one. But for right now, let's go ahead and do 1,000 pounds. We need to apply one more load, and this is going to be the shock load. The shock load is going to be at 20 degrees, and we're going to use a bearing load. We're going to select the inside and view this from the right, noting that currently it's pushing down. We want to rotate this at 20 degrees, which will match the angle of the shock. We're going to once again change the units to pound, and we're going to set this equal to 1,000 pounds. This is going to represent a fully compressed suspension, which will have a large load on the rear wheel, as well as a fully compressed shock. This load case 1 we're going to rename to compressed. Next, I'm going to right click and clone this load case, and then I'll activate the cloned load case. This next one is going to be a torsion load, and I'm going to set this as torsion 1 because we're going to have one direction and the other. For our loads, we now need to have a force up on one axle block and down on the other. So I'm going to change this force to 500 pounds, and I'm going to change the selection. I'm going to go to the left axle block, select the bottom face, and have that pointing up. Now I want to repeat that force by going to structural loads and selecting the top of the other axle block, setting this equal to 500 pounds as well. We're going to still continue to use 1,000 pounds as the shock load, which is not entirely accurate, but it is that upper load that the shock can apply. From here, let's right click on torsion and let's clone that load case. I'm going to activate it, and then I'm going to rename it. This one is going to be torsion 2. And in this case, we need to reverse the loads. And this can be done a few different ways. We can simply change the selection and move this one over to the bottom of the other axle block, or we could change the direction of the applied loads. In this case, I'm going to simply move it to the other axle block, and it's a much easier process to just redo that selection. Now that we have our second torsion, we're going to talk about applying some banking loads if the motorcycle is leaned. So we're going to right click and clone the load case for torsion. We're going to rename this one bank left. We'll activate it, and then we're going to modify these loads. First, we're going to modify force 6. We're going to change the style or direction type to use vectors. We're going to have 500 pounds in the X direction and the Y direction. If we look at this, you can see that it's pushing the swing arm up and to the right. We're going to modify force 7, and for this one, we're going to do the same. We want to make sure that we move that load selection to the bottom face, change it to vectors, and once again, we'll do 500 pounds in both X and Y. Next, we're going to clone the load case. Once again, we'll activate it, and we're going to rename this bank right. We need to modify the loads by going to force 8 in this case. And now we're going to be taking a look at banking left, or in this case, negative Fx. So we're simply going to add a minus sign to the Fx, and we'll do the same thing for force 9. So now we've accounted for a fully compressed load. We're using torsion to twist the swing arm, and now we're talking about an angled load, a banking load that's going to the left and to the right. There is one more case that we do want to account for. This last load is going to be a wheelie load, and this is going to be the case where the load is actually being pushed forward instead of to the left. So I'm going to clone bank right. I'm going to rename it. In this case, bank right will become wheelie. And then we want to take a look at the loads applied. First, we'll look at force 10. Instead of being minus 500x and 500 positive in the y direction, we're now going to be 500 in the y and minus 500 in the z. So we need to set x equal to 0, and we need to set z equal to minus 500. If we take a look at it, we can see the direction of the force is now pointing forward, which would be the case if the motorcycle was up on the rear wheel. We need to repeat that process for force 11, changing the x to 0 and changing the z to minus 500. Now we've accounted for all the various load cases that we do want to talk about. We need to make sure that our manufacturing methods and our materials are set up. We're not going to be looking at additive, but we do want to consider multi-axis or 5-axis milling, and we're also going to turn on die casting in the Y plus direction and the X plus direction. This will allow us to account for all the different manufacturing methods that are going to be important to the design. We're going to turn off cost estimation and then say OK. Notice that we do have a pre-check warning. It needs to look at the materials, so we need to have at least one material for all methods. So in the materials dialog, we're going to set all methods, and we want to take a look at some of the materials we have available. First, we're going to use aluminum. Then we're simply going to move down to other materials. In this case, we're going to go to a cast iron. We're going to move on to a steel material. We'll include stainless steel 3/16. Even though some of these aren't really going to be applicable to this design, it would be good for us to see exactly the difference between using these various materials. And then we're going to use a 1018 hot rolled material and we'll say, okay. Now, if we take a look at the pre-check warning, it's simply telling us that the geometry is too large, but we're not including additive and we're not looking at cost. So this gives us all the information we need. I'm going to go back to a home view, and then I want to take a look at the previewer. Oftentimes, the previewer will fail if we don't have a good line of sight between all of the various preserved geometries. In this case, we want to make sure that we use the previewer before we enable symmetry planes. We can see that it is building in exactly the area we intended. It is adding a little bit of material in the back, and that's because our obstacle stops just shy of the blocks, but that material will all get removed. Everything looks pretty good there, so I am going to enable a symmetry plane because this is symmetric left and right, but we can validate that by measuring. Let's go ahead and expand and show the origin, and let's measure from the outside of this boss to the YZ plane. We can see that we have 118.46. Let's redo that on the left side and make sure that we do have symmetry. Notice that it is different. So it is slightly offset to the sprocket side, which means that symmetry is not going to be a good option in this case. So it's a good idea that we validate that before we hit that solve button. Next, we're going to go to generate, select generate, and notice that again, it is going to require 33 cloud credits. So if you do want to follow along exploring the outcomes, you will be required to solve, but we will provide the data set at the end that we can explore and use for a simulation study. So once again, if you want to follow along, go ahead and generate the study, noting that it will take a good bit of time. Generative outcomes usually begin populating the Explorer interface within a few minutes, but in order to have all of the manufacturing methods and materials converge or complete, we oftentimes see at least 30 to 45 minutes for a simple study and up to several hours for a more complicated study. Because we've included several different load cases, manufacturing methods, as well as materials, we can expect this solve to take a good bit of time. But let's go ahead and check back in once we have some results that we can explore.